All right. Thanks a lot, Trey.
And Chris, as you get started, the one question that came in for Trey or you was in the late 60s, cathodic protection was used in the corrugated metal piping. This worked up until the bags had to be replaced. But the original installation did extend the life of the pipes. So, you know, just one of those things as you're covering this in more detail, there's the one question or comment that came in so far, Chris.
Okay. Yeah. Actually, well, I'll get to that in part of my slides. So,
okay.
Am I in control now?
You are. Just wiggle that mouse around and there you go, sir.
All right. All right. Well, again, thanks to Trey to giving some of the background on the CMP project. Chris Stoner, state engineer for NRCS here in Oklahoma, and I'm going to go into a little more detail about where we're at in the process, what kind of repairs we're looking at as well. CMP, as Trey indicated, stands for corrugated metal pipe. Actually, in our review, we looked at other types of pipe materials that have been put in dams throughout the history, and so it's not always just corrugated metal, but most of it is. 439 dams in Oklahoma were originally constructed with some kind of corrugated metal, either the entire principal spillway, tower, and barrel and riser, or the barrel as well. Some of them just had tailpipes, some of them had low-level drain pipes, and just lots of different configurations throughout that time period. The local sponsors and Conservation Commission had already made repairs on over 100 of these, but the repairs, as we've been talking about all day, are really not necessarily considered normal operation and maintenance. Come on.
That working for you, Chris?
Probably going to jump ahead about 4 slides here now.
You might, yeah. There it went for you.
Okay.
There you go.
Yeah, so for the pilot, we received funding for evaluation and repair of 50 dams out of that 400 or 300 or so that were still left that hadn't been repaired. All of these were greater than 50 years old, so they didn't meet remedial criteria, and all were low hazard. We selected 20 dams in 20 different watersheds covered by 14 conservation districts and in all 3 of the NRCS administrative zones. We got funding for construction, $2.5 million. And as Trey mentioned, that's a cost share 65-35, similar to what we do in rehab, 65 on the federal side and 35 on the local when we get into the construction. And then $500,000 for administration for doing the evaluations and the assessments, doing the design work, and then the construction management. And those were 2-year funds that we received back in October of 20. And so we've got till October 22 to expend those. We conducted field reviews on all of those 50 sites during COVID times. So that made it a little bit of a challenge sometimes to get groups together and get out on all the sites, but we managed through that. And we've got reports on all 50 of the sites that we looked at. Interestingly enough, 25 of the 50 that we looked at don't need any kind of action at all. They're still in good shape. I'm not willing to say that either here in Oklahoma or around the country that half of the dams out there that have metal pipes in them won't need any kind of work, but as far as the 50 that we chose to look at, that's the ratio that we had. We've got a couple that we're still looking at some additional evaluation that we need on them. That we could not get the camera into the pipes to evaluate those, and we're working to get that done. We've got 6 that the designs have been complete, 1 that construction has been complete, and 16 others that are currently in design. So what's with these sites that don't need any action? And I'll hit on more of these in more detail lately, but we found that 4 of them had already been repaired. 4 of them, the sponsors just chose not to pursue any additional work. Mentioned earlier some of the other types of metal pipe that we find in these. We had a couple that had wrought iron pipe. That stuff looks great. 3 of the sites were dry sites and the corrugated metal looked in really good condition. 3 of them were more grade stabilization structures above the flood control dams and not the flood control dam itself. And those didn't have any issues. And then all of the sites, except for 6, all of the 50 that we looked at had some kind of coatings applied prior to their installation. And 9 of the ones that needed no action had those coatings on them as well. Already repaired. And we'll discuss this a little bit more in lessons learned as well too. But as I said, we had 4 that the sponsors had already gone in and done the slip lining and tower replacement. And picture here, if you look up inside that barrel, you see kind of a double ring, and the high density polyethylene pipe was or slip lined or welded together and pushed up through that corrugated metal, and then we grout in between that, and we'll talk more details on that later on. Sponsor's choice. If it ain't broke, don't fix it. Some of them there was really no, even though some of these old designs, it was really hard to determine exactly what was going on with the pipes. Some of these were the low-level drains that were out into the pool, and in order to evaluate that, we needed to drain the pool. And some of these are out in western Oklahoma. That water's pretty valuable, so it wasn't affecting really anything in the function of the structure. So just chose to not pursue any repair measures on those 4. Wrought iron, man, if we could have put wrought iron in every one of the pipes that we put in the dams, we wouldn't have these problems. That stuff looks like it did the day it went in. Pretty amazing, but obviously the size and weight and all of that, we can't do the larger size diameters that we need. But that was quite remarkable how well the wrought iron has held up. Dry sites, obviously they don't get wet very often, or just fill up and pass the water on through and then dry back down. You don't have that potential for corrosion like you would with sites that are wetter. Grade stabilization structures. This one's kind of a head scratcher because we've had others that were built as grade stabilization structures that do need repairs that were part of the pilot as well. And we've got lots around that we've just put in through farm bill operations and things like that through the years that also need to be repaired. But of the ones in the pilot, 3 of these look in really good shape. And then finally on the coatings, and this is where I'll address Herb's question from Kansas. Of the ones he mentioned cathodic protection, and of the ones that we looked at, none of these were designed or installed with cathodic protection. They all were either no protection at all, but as I mentioned, 44 of the 50 had some kind of coating that was applied. And that has worn off over the years. In the picture on the left, you can see the outside were bits and pieces of the original coating. The one on the right, you can see the interior was also coated and how it's beginning to flake off. But they obviously extended the life of a lot of these metal pipes. So the kind of coatings that we did encounter, bituminous coated, basically asphalt coated pipes. Asbestos bonded. That's a good word these days. About putting asbestos in our watersheds. But bituminous coated and asbestos bonded. Bituminous coated, asbestos bonded, and paved inverts. So we did a lot of things trying to extend the life of these pipes. Copper was used in steel up through, in some cases, around the 60s when they quit doing that, in different coatings types, D, E, and G, and then galvanized corrugated iron pipes were some of the coatings that we found on the sites in the pilot. Another head scratcher is some of these that had the exact same coating do need to be replaced, whereas other ones still look in really good condition. So something else going on other than just the coatings. So where we stand today in the pilot, you've got a wide variety of spillway types and configurations, and we're looking at a variety of different repair alternatives for the 25 sites that are going to need repair. And I'll kind of go through a little more detail on some of those options that we're looking at next. So one we've already mentioned, and this was done quite a bit by our sponsors in the past, is slip lining and tower replacement. And so high density polyethylene or HDPE pipe is welded together, and from the downstream end, they then push that up through the original corrugated metal pipe. It's a smaller diameter pipe, but it's a smoother interior, so you get about the same flow out of it as you would. And that is something that we strive for on all of these, is to try to match the discharge to the original design calculation, so we don't overload the stream channels downstream, or we don't slow up the drawdown in the reservoir. So that's pushed through the pipe, and then the space in between gets grouted so that we have a good solid connection and no voids for water to penetrate through. And so now all the water just flows through the HDPE. If the tower was corrugated, like the picture on the far right here, then we replace those as well, whether they need it or not, just because it's a lot easier and a lot more stable and leak proof. I won't say leak proof, but more leak resistant installation at the end. So we'll put an HDPE tower on them as well. Kind of hard to see on this one, but it's not just black. We found out the hard way on some of these that had been replaced previously that beaver, for whatever reasons, like these. Probably just they were trying to get to a trickle of water that they're hearing somewhere, and so they were chewing up these plastic towers. Even though this HDPE is about 1 inch thick, they were completely chewing holes through that. So we now wrap those with a stainless steel expanded metal to kind of gnaw on those beavers' teeth if they try to chew on them today. And then we'll put a debris guard on top of these as well. And as I mentioned, if to try to keep the flows the same, if it had an orifice on it before and a vent pipe, we put an orifice back on top and with that vent pipe as well. Low level drains. Some of these, if the tower was actually out in the reservoir, like the one you see on the far right there, that's pretty simple. You just replace the gate. But some of these, the tower was actually embedded in the embankment, and if it's deep enough, we're going to have to go in and excavate out to replace that pipe and put in some kind of inlet, like we did here on a rehab job, to allow that water to get to the tower and get to that gate. Other cases, it's kind of just towards the toe of the dam. And so we're going to go in with kind of a buttressed type concrete and keep the side slopes of the embankment from coming down and filling back in around the hole, and just leave that excavated out in front of that. So that'll be some new concrete work that goes on there. Said some of these had tailpipe extensions. They would run reinforced concrete through the main body of the dam, and then they would tie onto it with CMP to save cost, and take that to the outlet channel. Couple of these, that little CMP tailpipe section was only about 20 to 40 feet long. So we're hoping that in some of those cases we can just remove that, install a plunge basin, and cantilever the water through the concrete pipe out into that plunge basin, and take care of just remove the corrugated metal that way. There's other ones that have extremely long tailpipes, and those are going to have to be replaced with a more modern, longer lasting type material. And then since we were doing a more of a pilot and just trying to explore all the alternatives, there's a couple of dams that we are going to do full replacement on, and using the same technologies that we've done in rehab jobs. Cut and cover on one of them, basically excavate a notch through the dam and install a brand new pipe. And then in another case, we've kind of gone, our go-to anymore on rehab is boring and jacking, and we will bore a hole and shove a new pipe through the dam, and abandon the old corrugated metal pipes that way. What we found so far in the analysis is age is a factor. Obviously, older you get, the more potential damage there's going to be, except in the wrought iron. Those were put in like 1950 and still look great, but corrugated metal, not the case. Pipe gauge, you think, well, the thicker it is, the better. We had one, and that was 8 gauge, which is thicker than these others below it. And that one that we looked at, that one failed. So we had 100% failure on that one. 80% failure rate on 12 gauge to 14 gauge, and 66% on 16 gauge. So that would indicate thinner might be better, but yeah, that's, we're pulling things way out of the air before we know a whole lot else that's going on there. The coatings, it doesn't seem like there's any correlation at all to sites that need repair and those that don't, based on the coatings. Same coatings, same counties, same watershed. One pipe needs it and the other pipe doesn't. So try to figure out, what might be the cause there. Probably something during installation where those coatings got scratched, or if there's, if they were some discontinuity of materials, things like that. So we just don't know yet. Wet versus dry. Obviously the dry sites seem to be better, but we have some wet sites that look just fine as well, and others that need work. One of the things we're thinking may be an issue is if you have standing water in the pipe or in the corrugations, you're probably, that's just more opportunity for that water to interact with the pipe and cause some problems. Location. When we picked these sites, we tried to pick a variety of the different styles and different locations. And so we spread these across the state. But that doesn't seem to have any real correlation either. Multiple sites, again, in the same county that need replacement and some that need no action. Same watersheds, same conditions, not a defining factor that we've seen so far. Soils, we do know we have some soils in parts of the state that are more prone to cause corrosion, and coarser grain soils that may get picked up in the floodwaters and flow through those pipes may be a little more abrasive and cause some issues. We don't really know, haven't really studied that in that much detail yet. So that one's up for more debate or more study. So lessons learned thus far. We're still learning things. A good inventory. if you don't have a large number of sites, might not be an issue. With us, it was with the numbers that we've got. It's not the whole 2,000, but it's or 2,100, but it's 400 and something of them that we had to go, or that we found of that 2,000 that needed some, or that had metal in them to begin with. A good filing system to know what you've got out there, that your NID's been updated, or your as-built drawings, which is the next item, are in good shape. Lots of variations in designs when you look at the as-builts. We don't build dams like they did back then, so you'll see some really strange things. The quality of those and the filing system on those too, if you can find them, the quality may not be as good as you would like to see. We've got all of our scanned now, and on a scan drawing, you can zoom in and see some things a little bit better. But even in that case, on some of those, that didn't necessarily help us as well. Communication expectations. Working closely with your sponsors, explaining the process, explaining what might be involved, as well as knowing, what's already been fixed. If they have some information, work that was done, and for whatever reason we didn't get notified, didn't get our as-builts updated, those kinds of things. Knowing what's other repairs have been made, but also, again, we go into a major construction on some of these. One, they're going to have to be drained. Two, it may be an extended time period that construction's going on. So just being upfront and knowing what's going to be going on. And then in the inspections, be prepared. Again, it's not going to be the same dam that you would look at if if we built one today. So have a good idea of where things may be, where the pipes may be, what they're going to look like when you do find them, if you do find them. And then document all the issues and concerns that you see when you're out there. Take it as a chance to do a very detailed inspection and assessment of the dam that you've got. I mean, you're there, you might as well do the best that you can on making a full inspection. Some of those other issues that we've noted, similar to what Steve was talking about down in Texas, wave damage. We hear a lot of this from our sponsors, not just on these 50 dams, but on other ones as well. A lot of these might have been designed with wave protection, with a vegetated wave berm in the beginning. Why did that fail? Why didn't it work anymore? Should we have used rock? Were the fences down and it got overgrazed, or was it a water loving type vegetation and the water level doesn't stay up there? Again, Western Oklahoma, they go up and down and up and down. So we evaluate all of these. We try to figure out what really should have been there, and what the needs are. The fix is really easy. I mean, it's not cheap. It's not normal operation and maintenance, but it's relatively easy design anyway. Reshaping this and either putting in vegetation and putting the fences back up, or lining it with riprap and protecting them that way. Sinkholes, not real common, but more common than I'm comfortable with here in Oklahoma. We have a lot of gypsum, subsurface gypsum areas that when they come into contact with water, just kind of disintegrate and leave us with sinkholes. And many of those have been worked on for years with grouting programs, going in and filling up the holes. But with gypsum, you pretty much just delay the inevitable. It's going to still, if there's any more gypsum there, it'll be 5 or 10 years later and you'll have another hole just as that disintegrates. So this particular case, this dam had a long history of repairs, and we were able to, through remedial funding, because it had been a known issue for such a long time, go in and actually we decommissioned this one and took it out of service, cut a notch through it, and lined it with a riprap chute for that grade stabilization protection. Drainage systems, Glad, West Virginia. I'm going to be calling y'all about what you've done with some of these, because this one kind of scares me a little bit. All these dams were built with a pretty extensive drain system when they were originally installed. And at least here, we haven't done a whole lot with those drainage systems in the past. When I first started my career, I was always told, go do your dam inspections in the middle of the summer. And that way, if you see anything that's bright green, it probably tells you that you've got some seepage. And so looking at this picture here, this bright green line straight across the back toe of the dam, and that's up on the dam. It's not down at the toe. It's up on the dam. So we've definitely got a line of seepage coming through this area and affected everything downstream of the dam. Something that again, we haven't really explored to date, but I've looked at other aerial photos of this same time period and find quite a few that look just like this. Also mentioned debris guards. Some of the older ones were wooden structures, or even steel structures, either through corrosion or through just damage by getting hit with trees. They're going to need some TLC, and just like the drainage systems, it's a critical part of the original design of that structure, and for it to function properly. So that needs to be addressed as well. So where are we going from here? We're going to continue with the design work on the rest of those structures. Hope to begin construction on some of those that are done here relatively soon, and then ultimately develop a final report for the whole pilot project, detailing what we found through all of the different sites. And the goal at the end is that we'll develop a best repair alternative for the remaining sites in Oklahoma, and have that available to help out other states as well that are dealing with the same kind of issues. And with that, Ray, I'm going to I guess open it up for any questions. Thank you,
Chris. Thanks so much, Chris, for that presentation. And for you and Trey, our first question comes in. Any concerns with the reduced capacity when slip lining the preliminary primary spillway?
Like mentioned, most of the time, or a lot of those earlier designs were, they had orifices put in them so that they wouldn't flow full anyway. Mm-hmm. And also that HDPE pipe is smooth walled, so it's extremely slick, very, very low resistance to the flow. So you can reduce the size of that significantly, a couple of inches in diameter, and still maintain the same amount of flow. Or it's just maybe a slight change in the size of the orifice to match the flow rates. But mm-hmm. So far, it's not been an issue. We've been able to match them all relatively close.
Very good. Second question came in, and that is for information. In 2019, they did an analysis of the national inventory of dams and found that 2,276 watershed dams in 26 states had all or a portion of the principal spillway pipe was corrugated metal piping. Over half the watershed dams with CMPs were more than 50 years old. 2,100 of the watershed dams were in 7 states. Iowa had the most, with 906 watershed dams with CMP. I suspect that there are actually more than that shown due to the missing data for some dams in the national inventory. Any comments on that, Chris and or Trey, that come to your mind?
Well, I would just say that that's where, we know that there's a lot out there. It's not just an Oklahoma issue, it's a national issue. And hoping that, some of the things that we can come up with these design alternatives will be able to help those other states as well.
We've always heard that Iowa had a lot of corrugated metal pipe components and always thought that they had the same issues that we did. And I think this is a good opportunity to show that this is a national problem and not even just a problem of the states that were on our working group.
Mm-hmm. Big portion of it. And Dan, I see you're typing an answer, but love to hear from you too, Dan, if you had something on this, and then we'd let you get back to your typing.
I'd like to say thanks to Chris and his staff too, because this is an excellent working relationship. Tammy Swatsky, who runs our conservation program that has our watershed program in it, works very closely with Chris and his staff, and we have folks in the field, and they go out, hand in hand on these assessments. And anytime we have an issue that we need a trip report or we need an engineer down there, it's very quick response, and we would have been lost in trying to deliver any type of pilot project without NRCS and their engineering staff. So we really appreciate that.
Thanks, Trey. We got another a question here. Out west in Utah, for example, the CMP won't last but about 25 years, the individual said. In most of our soils, it is a big problem out here as well. So out west, Utah in particular, and many of the western states having some failures even sooner. Let me give one more chance, one more shout out to Dan. Dan, you want to respond to some of this?
Sure, Ray. That's one of the things that that came out as this work group progressed through listing and addressing issues and looking at solutions to problems. And in the process of that, we were joined by a gentleman that's well known to many of the folks that are with us today at the meeting. And that's John W. Peterson, the former executive director of the National Watershed Coalition. And I guess in response to the data that was offered about the 2019 analysis, the bottom line is the mess is bigger than what we started talking about with that work group. It extends beyond the boundaries of the states represented on the work group. One of the things that early on, as John Peterson reviewed some of the work that the work group was doing, was that he felt like, with his expertise, perspective, and his years of service, that we were really on to something. And I think that's very true. I would commend all the folks on that work group for what they've done and the time they've invested in this. And I'm hopeful that the work that Chris and his folks are doing will give folks a glimpse of possible ways to begin to address this problem. This is a companion to the kinds of things that the West Virginia folks were talking about. But this CMP thread does run through several states and many structures. So hopefully the pilot will reveal some things about cost, about design, about analysis in the field to determine the needs and the actions that would be appropriate. And I really appreciate Chris's input and the initiative he's taken to do this pilot.
Thanks so much, Dan. And back to you, Trey. I think you had some other comments you wanted to make also.
No, I agree with what Dan said, and the opportunity to work together on this. We can see that there are these issues out there, whether corrugated metal pipes or other components, and the chance to avert major expenditures or emergencies down the road with a dam failure or something like that, where the federal government and the state governments are having to pour a lot of money into it. It's a lot better money, that we spend today than we'll have to spend, sometime in the future. And also, you hear a common theme from West Virginia and Oklahoma. The local and the state are willing to spend money. It's just a matter of level of resources. You know, a lot of the, as Chris outlined, local sponsors with state help had made repairs on many of these that they looked at, but it's just that we can't handle them at the scope that we see, and continue to try to provide the support to all the other different aspects of keeping the watershed program going. And so being able to look at a pilot project and increase the size of a cost share program on this type of repair on what might be remedial. And some of these corrugated metal pipes were similar to Utah. We first saw their failure beginning during the engineered life, or the beneficial life of the dam. They were noted at that time and just didn't have a chance to get those repairs made, even though now they've gone past that. So I think it's a great project. I think it's really, again, I salute Kevin Farmer and leadership at NRCS for being willing to take on these kind of projects, and for Chris with an already overloaded staff to jump in and get the work done.
Outstanding, fellows. Chris, then any other comments that you got? That one thing again that you wish you would have told a couple hundred of your best friends?
Well, just what Trey was indicating there. I mean, yeah, we couldn't do it without the partnership as well either. So, great working relationship that we have with them, and yeah, we're a little short on staff, but we're making it work, and doing that with their help as well. I guess that, one final thing is, this is a kind of alluded to on some of the later slides. This is just one issue that's out there. There's the draining issue and the front slopes and things like that are all similar, and hopefully with this pilot, we can look at expanding that to doing more of these types of things that are beyond that normal O&M.
Sure. And as we were finishing up, we had a really good question come in. So let's deal with it, Chris. And then do you have an assessment and or a solution report ready that you can share? On Tin Horns, great comment there. And would it would really help us from your experience, Chris, and if you are planning on preparing one. So
what we've produced so far was basically a single engineering report with 50 appendices that dealt with all of the 50 sites that we looked at. So it was just that initial assessment. The goal is, yes, we will have a final report, with what we would suggest if you have this type of structure. This is, a repair alternative that you would, could consider. Or if you have this, you might want to consider that. This is the cost of this one. This is the cost of that. Those kinds of analysis to go into that final report. So that'll be probably a year and a half down the road before that's available, after we've done all the construction and finish that report.
Thanks, Chris. We also had one hand up, and I'm going to just call on that individual to make sure if they had a question or not for our last two speakers. If you've got a question, go ahead and ask it now. Okay. Must be okay. Okay.
Ray, I might say one other thing, and this is, I think the message one is for local sponsors, especially who don't have any money or resources, or think that their state doesn't have resources, don't just stick your head in the sand on these issues like this. Continue to advocate for them, whether, because if we bring together all these different districts like we're shown on the map that have our 400 corrugated metal pipe structures, and we go to the legislature, that voice can be heard. And then if we as states go to Congress and say, this is an issue that needs to be addressed, then our voices together, you may not be able as a single conservation district or board be able to solve a problem or even have anywhere close to the funding to work on it. But, if we work together, I think we can raise this to the level that something will happen. And we're seeing that Congress has responded with operating funding, and those at NRCS have responded with these pilot projects.
Outstanding. Very, very good. So appreciate your your program, your presentation, the preparation that went into this, Chris and Trey. Very outstanding, very enlightening. We appreciate it very much. And we'll move to our next speaker now.